Hi and welcome. My name is Mrs. Burns, and we are already on lesson 9 of our chemistry section. And today we will be talking about chemical equations part 2. You can find this in section 4.3 of your BC Science 10 textbooks. So what do we already know? The other day we talked about what are chemical equations and about this idea, the law of conservation of mass. So we know that chemical equations demonstrate what substances are combined or formed in a chemical reaction. So when we write a chemical reaction equation, we're representing a chemical reaction. So here on the left, these are our reactants. And on the right side, we have the products. And in this case, there's just the one product. And this arrow here means produces or yields. So yields is just a fancy word to say produces. So the reactants come together and that produces the products. So today we're going to learn how to balance some of these chemical equations, because this is what we would call a skeleton equation, so it's not yet balanced. First thing you need to do when you want to balance a chemical equation is you need to double check that you actually wrote the equation down correctly. We spent a lot of time on this in class. It's all about sections 4.1 and 4.2 of your textbook, and we talked extensively ionic compounds, how to write them, naming covalent compounds. What about when you have a multivalent metal or a polyatomic ion? So please double check you wrote down your formula correctly. And then we write what I just called the skeleton. It's spooky because Halloween is coming up. The skeleton equation. So our skeleton equation for this example here would be methane is CH4 plus oxygen yields or produces water and carbon dioxide. So you need to know how to create that skeleton equation. If you're not feeling comfortable, make sure you practice lots and lots and reread that section and rewatch those videos. Alright, once you've done that skeleton equation, you're on to step 2, and you're going to balance that chemical equation. So there should be the same number of atoms on either side of your arrow. What I would suggest is that you start with carbon, then you move on to all the other elements, but I like to balance hydrogen last. I just find that to be helpful because there's often quite a few hydrogen molecules, and usually they're pretty close to being balanced by the end. Now, don't be discouraged. I really mean that. It's going to take a lot of practice and a lot of trial and error. You really are going to have to erase and retry. That's why we'll practice with the whiteboards in class. So let's try this one together. We just said, well, we had methane plus oxygen makes water and carbon dioxide. So let's look at our C's. We have one C here and one C here. Are our carbon molecules, our carbon atoms balanced? Yes, they are. That's great. So I'm going to erase them for now. Oopsies. So next, let's check the oxygen molecules. Here we have 2 oxygen molecules, and here we have 1, 2, 3. So that 2 here applies to our oxygen, and this 2 here applies to our oxygen. So this side has 2 and this side has 3. That's no good. What are we going to do here? Well, we can stick some coefficients on the lines I've provided for you. Now, the first thing you notice is that this oxygen is all by himself. So we have an odd number on the right side and an even number on the left side. Let's even this guy out by putting a 2 there. Now we have 4 on the left. Now we only have 2 on the right, so let's put a 2 here as well. And now we have 4 on both sides. Way to go. Let's erase that there. And now let's double check. Did we mess up the carbons that were already balanced? Well, there's still 1 carbon, 1 carbon. They're good. Now we have 2 O2 molecules. So that's like saying over here we have O2 is the same as oxygen bind with oxygen. So that's one oxygen Lewis diagram. This is one O2. Now in this case, now we have two O2s. So in total, we actually have 1, 2, 3, 4 oxygen molecules on the left. And now we have 2 here. So this 2 applies to the H and to the O. And here we have 2 O's, so we have 4 on the right side as well. Fabulous. That is all balanced so far. Let's get rid of these so that we can make it really clear for the last one. Last but not least, we are on hydrogen. Here we have 4 hydrogens, and here we have 4 hydrogens, because if you notice that 4 is right beside the subscript for that hydrogen. And here we have the subscript 2 beside the hydrogen, but we also have the 2 there. So that's like saying H2, there are 2 H2s, so that makes 4 H's. Because H2, the 2 H's are together, like so. So we have a total of 4 H's. Now I can clean this up for us and just make sure that we are all set to go. Let's do another color. We have on the left side 1 carbon. On the right side, 1 carbon. We're good. On the left side, we have 4 oxygens. And on the right, we have 4 oxygens. Awesome. On the left, we have 4 hydrogens. And on the right, we have 2 times 2 is 4 hydrogens. Are we balanced? Yes, we are. So let's just remember this law of conservation of mass we learned last video, remembering that each element is conserved during a chemical reaction. So that's why we need to have the matching number of atoms. This is why we're balancing here, because we need to make sure that we show this conservation of mass, because it's actually happening in real life here. So we need to show it with our numbers. So let's try a couple, because this is tricky. When I see all these letters and numbers jumbled together, I like to separate it out and put a couple of lines for myself so that I have somewhere to write on and to make changes and mistakes. So first things first, let's count the N's. We see that here we have 2 N's and here we have 1 N. Now because this NH is not in brackets, the 3 does not apply. If it was written like this, then the 3 would apply to the N. The 3 does not apply to the N here. So we only have 1 N on the right and 2 N's on the left. So we need to even this out. So let's put 2 N's on the right side. So now we have 2 N's on the left and 2 N's on the right. Awesome. The N's are balanced. Well, let's double check, oopsies, our hydrogens now. Now we have 2 times 3 hydrogens, because this is NH3 here. And now we've just put 2 NH3, so that's like saying that we have 2 NH3. And now if we count the hydrogens, we have 1, 2, 3, 4, 5, 6 hydrogens, or you could say 2 times H3, 2 times 3 is 6. So if we have 6 hydrogens here, on the left side we only have 2, so 3 times 2 is 6. Is this now balanced? 3H2 plus, this is just an invisible one that you don't need to write, we just know that. 1 and 2 yields 2 NH3. Yeah, that's wonderful. Alright, last example on this page, nitrogen monoxide plus oxygen yields nitrogen dioxide. In this case, we have a word equation, so we need to make it into a skeleton, spooky skeleton equation. So nitrogen monoxide is mono N, mono is 1, oxygen plus oxygen molecule yields nitrogen dioxide. So when we look at this, is it balanced? Well, we have 1 N on the left and 1 N on the right. Wonderful. But now we have 1, 2, 3 O's, and on the left we only have 2 O's. So what are we going to do? Well, we could put, say, a 2 here, and now we have 4 O's, but now we have 2 N's. on the right. So the ends are no longer balanced. So we need to make maybe 2 ends over here. So I'm just going to clean up some of these circles I've drawn. So we have 2 N's and 4 O's on the right. And now we have 2 N's. This one has 2 O's and this one has 2 O's. So we have 2 N's and 4 O's on the left. Hooray, we're balanced. That's great. And again, you can just leave this as a blank spot. You do not need to write a 1. It wouldn't be wrong if you did, but you don't need to, so don't worry about that. All right, let's go on to the last page here. Some helpful tips when we start to balance, because they're not all that easy. They do get really complicated. So the first thing you need to do is double check that you actually wrote your skeleton equation correctly, because sometimes we have ionic bonds, sometimes we have covalent bonds, sometimes you're going to see multivalent elements like iron 4 phosphide, for example. So what do you do with that? Make sure that you write it correctly. What about if you have polyatomic ions? When you have NO3 minus, you're going to have to deal with brackets in this case and balancing with brackets, which we'll get to in a couple of days once we get more comfortable. But it's very important that you write that first equation correctly. The next thing that you want to double check is that when you change from a word equation to a skeleton equation, that you know what each of these words mean, because sometimes you get elements that are diatomic. And so they will come together and form a covalent bond with themselves. For example, oxygen, when you see that word oxygen, you know that the skeleton equation will include an O2, just like so. So we call this the special 7. And we see that it makes a 7 in our periodic table, and there are 7 of these elements. So hydrogen and hydrogen will make hydrogen gas like this: nitrogen gas, oxygen gas, fluoride gas, chlorine gas, bromine gas, and iodine gas. So they will come together. These are diatomic. So you just need to recognize that when you see the word. So when you start, I recommend balancing the carbons first and ending by balancing your hydrogens. And it can also be easier if you balance the compounds before you balance the single elements. So if you've got this big, long polyatomic ion, balance that first and then leave your O2s and your NOs to last, because they can be manipulated a little bit more easily. And remember that you're only changing the coefficients, just the number in the front. You're not changing the subscripts. So again, let's remind ourselves that the coefficients I put as lines here. Oops, that one disappeared. Coefficients are here. And then these here are the subscripts. So we're not changing the subscripts. We're only changing the numbers on our lines. And last but not least, please double check at the end. Double check, triple check, quadruple check all the time that you have made sure that all of the number of atoms on the left equals the number on the right. So here I checked that there were 2 N's on the left and 2 N's on the right. 4 O's on the left, 4 O's on the right. That way you know you did it correctly. All right, this can get tough, so we're going to practice it over and over and over again. Please come to class tomorrow ready to learn.